So hello students, today in the second video for uncertainty and measurement we are going to take examples of multiplication of uncertainties. So let's start our video. So we will take an example of area of rectangle. So suppose some rectangle is given. Okay. They have given one example for rectangle. Suppose this is the rectangle and its length is 6.5. So here it is given as 6.5 plus or minus 0.7, and breadth, this breadth is given as 3.2 plus or minus 0.5, 3.2 plus or minus 0.5 centimeters. Okay, so in this way length and breadth is given. So they have told us to find uncertainty of this. So we will now try to solve this. So area, first they have asked to find area of this along with the uncertainty. So area is given by length into breadth. So area is given by L into B, as we know very well. So here length is 6.5, this value, and tolerance value we will take later on, 0.7 we will do later on. And now breadth B. So breadth is equals to 3.2 into 3.2, which will come to 20.80. So 20.80 is the area of this, okay, this rectangle. Now this is the what we are measuring here. Now we have to calculate the tolerance value of all this. So for multiplication now we have to add, that we have to remember. So this formula will be like this. Suppose delta A means that absolute uncertainty or tolerance value of whole of the area upon the real area what we have calculated, that will be around 20.80 what we have calculated here. It is equals to delta L, means delta L for length means that is 0.7 upon L, that length is 6.5, then plus delta B. So breadth is delta B is 0.5, this value, and then upon 3.2 upon this. Okay, so B, breadth means B value, so B 3.2 means B value. Okay, so in this way we have to solve this question. So let's solve this question. So let's solve this. So this is B. Okay, so now we will solve this question using this formula. So delta L upon L. So delta L means 0.7 upon 6.5. So 0.7 upon 6.5 will be our delta L upon L. So this value, and delta A upon A. So area we will substitute all these values whatever we know. So this is delta L, I will write here. So delta L upon L, delta L upon L is given by 0.7 upon 6.5, this upon this, and now delta B upon B. So delta B upon B will be given by, so 0.5 divided by 3.2, 0.5 divided by 3.2. So now we will substitute these values, delta L by L here with this 0.7 by 6, and delta B by B with this 0.5.3.2. So and area value, A value we will substitute here, 20.80. So let's substitute and find out. So here we will write delta A upon 20.80, delta A upon 20.80 is equals to delta L upon L means 0.7, this value is equal 0.7 divided by 6.5, so 0.7 divided by 6.5, then plus this 0.5 divided by 3.2, 0.5 divided by 3.2, 0.5 divided by 3.2. So in this way now we are going to solve this equation and get the answer. On the next page we will solve this equation. So here, so we will write this. So delta A upon 20.8 is equals to 0.7 upon 2.5 plus 0.5 upon 3.2. So let's solve this. So this will come delta A upon 20.8. So 0.7 divided by 0.7 divided by 2.5 will come to 0.28, plus 0.5 divided by 3.2 will come to 0.15. So delta A is equals to 0.28 plus 0.25 will come to 0.43. So therefore delta A upon this is 20.8. So now delta A equals to 0.43 multiplied by 20.8, so which will come to 8.94. So 8.94. So delta A we got as 8.94. So let's find out the uncertainty of this. So we got area. Now we know area, so we have to write in this way. So 8.94 is the tolerance and area is 20.8. So we will write area 20.80. What we have got here, 20.80 for area, plus or minus. Area was here, so you can see 20.80. This was the area. So 20.80 we have written. Now we will write this, what we have got, 8.94. So plus or minus 8.94, tolerance value or absolute uncertainty 8.94. This is measured value. This is what we have, tolerance value that we have just now calculated, delta's value on this delta's value. Now we will find percentage uncertainty of this. So percentage uncertainty means this tolerance value or this uncertainty, what is there, absolute uncertainty upon this measured value into 100. So this upon this, so equals to 8.94 upon 20.80 into 100 will give us uncertainty, percentage uncertainty, that is coming to 42.98%. So 42.98% is the percentage uncertainty of this, area of this rectangle. So in this way we can calculate the area of this rectangle and uncertainty also, and percentage uncertainty. So along with that we can calculate. Now we will take a similar type of example related to multiplication. So let's take this example. So suppose they have given one cube and they have asked volume of the cube. So suppose they have given so we will draw a cube like this. They have given a cube. Okay, they have drawn a cube here and they have asked us to find the volume of this cube. So for this we have to actually do according to that multiplication rule, that is addition only, addition of the uncertainties. So suppose they have given length is there. So length here, so length plus delta, length, suppose they have given this length of this as we will take some example as 4. Okay, so this is 4, this length is 4, so everything is 4, all this length, breadth and height, everything is 4 because it is cube, so everything is same. So now length they have given as 4, okay, 4 centimeters. So 4 centimeters. Okay, so we will write here 4. Then they have given tolerance value also, suppose. So tolerance value they have given as plus or minus 0.5. So we will write here 4 plus or minus 0.5. So this is the length. Now they have asked us to find volume of cube, of this cube, that we want to find out. So for this you know the formula, volume is given by side cube. So for this 4 cube, so 4 cube is equals to 4 into 4 into 4, so the 16 for the 64. So 64 centimeters is the volume of this. So we got volume, what we have calculated here. Okay, measured volume. Now we will find delta value. So all these delta values we want to find out. So for finding delta values we have to use our formula. So we will take this formula, delta V upon V is equals to delta L upon L, because 3 L's are there na. So plus again delta L upon L, then again plus delta L upon L, means this 4 and this 4 for this 4. So all this 4. So all these values you have to substitute here. So this 4, this is for this 4, this is for this 4, and this is for this 4. So we will now find out this tolerance value, this delta 5 delta 5 0.5 is there, this is for delta 0.5, and this same 0.5 for this second delta length, and this third 0.5 for third delta length. So we will substitute all these values, and length is there, so length also 4 we will substitute here 4. So all this we will substitute and we will get delta volume we want to find out, and we just now we found out this is equals to 64. Here we got it 64. So now we will substitute these values. Okay, so let's substitute the values. So now delta V upon volume is 64 equals to delta L. So delta L is 0.5, this is that, upon 4, this is the length. Then 3 lengths are there, because length cube it is there, so volume of a cube is length cube. So here this second delta L by L, so this is 0.5 divided by 4. Now third one, so third one is also plus 0.5 delta L, same value, divided by 4. So now we will solve this equation. So I will write on the next page. So here delta V upon 64 equals to 0.5 plus 0.5 plus 0.5, and then upon 4 it was upon 4 and upon 4. So now here delta V upon 64 equals to, now this denominator is same, so we can take 4 as common here at the bottom, and then 0.5 plus 0.5 plus 0.5. Now we can say 5 is a 15, so means 1.5. So delta V equals to, delta V divided by 64 equals to 1.5 divided by 4. So now we can do is what, 1.5 divided by 4. So here we can write delta V divided by 64 is equals to, now it will come 1.5 divided by 4 will come to 0.38. So 0.38. So delta V equals to 0.38 into 64 into 64. So here when we are doing this, so it is coming to 22.32. So 24.32. So 24.32. So we will write 24.3 only. So here we will write 24.3. Now we will write the volume. So we got delta volume, and we know the volume as 64. So volume as 64 was here. So volume was 64. So volume is 64. We know this, and we know delta volume also. Just now we calculated here 24.3. So we can write it as 64 plus or minus 24.3. So we will write on the next page. So therefore V equals to 64.0, okay, 64.0 plus or minus 24.3, this value, plus or minus 24.3. So this is the volume. Now we want to find percentage uncertainty of this volume we have measured. So percentage uncertainty is given by 24.3 divided by 64, this value divided by this into 100. 64.0 into 100 will give us percentage uncertainty, that will come to 37.98, but 3 significant figures we are taking, so it will be 38.0%. So in this way you can solve this question. So this multiplication of uncertainty is done. Now in the next video we will take division of uncertainties, and we will take few complicated examples also later on. So thanks for watching the video. Thank you very much.